What's one more thing in a long chapter, right? We're all friends here. By now, you hopefully understand that covalent bonds are the glue that holds together molecules made up of nonmetal atoms, like these two molecules of hydrochloric acid, HCl. But there are two molecules here. In a sample of liquid hydrochloric acid, these molecules will hold on to each other, keeping the molecules as a liquid and not just flying off randomly as gas particles. Intermolecular forces, which I'll generously abbreviate as IMF as much as I can, are the attractions between these molecules right next to each other that hold them together. These attractions are weak and temporary. This affects all the properties of matter that we learned about way back in the beginning of the year. So solids have very little space between their molecules. And this is because the intermolecular forces between them are very strong and hold these molecules close together. Gases have lots of space between their molecules due to very weak intermolecular forces. And liquids are kind of in the middle. Liquid molecules hold on to their neighbors enough to flow past each other, but not that much that they're becoming a solid and locking together. We've used the terms polar and nonpolar to describe how symmetrical a molecular bond is. We can also use this word dipole, which means the same kind of thing. Dipole just means two poles, so a molecule that has one end that's a little more negative than the other, and another end that's a little more positive than the other. In this picture of HCl, the chlorine side has a crowd of unpaired negatively charged electrons around it, so it's more negative than the hydrogen side by comparison. This makes the hydrogen side of the molecule more positive than Cl by comparison. This little squiggly sign here, this guy right here, that shows up written on either side of the molecular, just looks like an upside down letter D or a snake, and it means slightly. So the Cl is slightly negative compared to hydrogen, and the hydrogen side is slightly positive compared to the chlorine. A dipole-dipole force is when two of these molecules attract each other. This is just like if you put two magnets next to each other in the bottom picture, with the north pole of one magnet attracting the south pole of the other. So in this middle picture with the two HCl molecules, the relatively negative chlorine side of one HCl is attracted to the relatively positive hydrogen side of the other HCl. And this plays a big role in letting nearby molecules of a substance hold on to each other and not just drift away. One important type of intermolecular force is hydrogen bonding. This is another temporary attraction between a hydrogen on one molecule and either a nitrogen, oxygen, or fluorine on another molecule. Atoms of these three elements have plenty of unpaired non-bonding electrons around them, and all that concentrated negative charge will attract the positive nucleus of a hydrogen atom if it's close by. Since hydrogen is small and doesn't have a lot of its own extra electrons that would get in the way and interfere with the attractive forces. If you remember hearing about this in your bio classes, the reason hydrogen bonding is important is because it's what lets water molecules hold on to each other really tightly and gives water a bunch of interesting properties. You might ask yourself, how can we remember what a hydrogen bond actually is? Well, let's ask Mr. Hydrogen. Mr. Hydrogen, are you the only one involved in hydrogen bonding? F no. Just remember that hydrogen bonding always has to involve hydrogen, since it's in the name, and then one of these three elements. So hydrogen bonds form between a hydrogen on one molecule and either a fluorine, a nitrogen, or an oxygen on another molecule. Hydrogen bonds are stronger than simple dipole attractions, and this, again, is what makes water molecules hold on to each other so strongly. It lets the electrons around each water molecule's oxygen hold on to the hydrogen atoms of two other water molecules, creating this really interlocked network and web of water molecules. If we look at properties of similar molecules, we can see the effect of these bonds. Each of these molecules listed has two hydrogens and one atom from group 16 of the periodic table. Tellurium, selenium, and sulfur all behave and react like oxygen, but look how different these boiling points are. The first three compounds, H2Te, H2Se, and H2S, all boil at temperatures where water is still solid ice. Water, H2O, needs to absorb a lot more heat energy, at least 100 degrees worth, more than these other similarly structured molecules. This is great news for us, since this property is one of the things that allows living things to exist on planet Earth. Anyone know what this is? That's right, one kid who I'm imagining is talking to their computer or phone screen right now. This is Velcro. And how does Velcro work? If you've never actually looked closely at Velcro, the one softer side has fine threaded loops of the material, and the other more prickly side is a bunch of little plastic hooks. When you push the pieces together, the hooks grab onto the loops and the sides stick together. This is how hydrogen bonding works too. Each single Velcro hook's strength is pretty weak, but when there are lots of them, the overall connection is strong. Each individual hydrogen bond isn't strong enough to do much, but an enormous number of them inside of a water sample ensures that the molecules in a water sample hold on really, really tightly to one another. Here we see the covalent bonds between the oxygen and hydrogen atoms that hold each water molecule together. The hydrogen bonds are the dotted line attraction that connects water molecules next to each other. The same is true here for HF molecules. The solid line covalent bond between each H and F forms a molecule, but each green and white molecule is held to another green and white molecule by a temporary hydrogen bond, shown as a dotted line. And just like that, another chapter comes to a close. Finish the form, get ready to review, and your test is next Monday.